And good morning to everybody. I'm not actually ready right yet. I saw the time was getting close, so I hit the start button. It started the 60-second timer, and I panicked. I lost it. I dropped the ball. Okay. To get this back on track, let's start properly. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So good morning to everybody. So what, yeah, right. What threw me at the very last moment was that I was opening Mitchell's text-to-speech, came up with a bad portal thing, and then I remembered, oh sorry, a bad gateway message, and then I remembered that Mitchell said to use the new system, so I was just opening that, and I can see that there is an upcoming stream. Am I live? I don't know. It looks like I am. I can't even see the chat window right now. That's how disorganized I am, because I've got stuff open all over the screen. Okay, where is this chat window? Where is the chat window? There it is. Okay. Slow it down. I might have to do this the old-fashioned way. Oh, something just popped up on... there we go. The betterportal.app thing has just woken up, and it is catching up with a whole lot of the chat.
John.
Hey, that worked. Okay, I've got to turn that volume up a little bit though. It wasn't quite loud enough. All right, I'm going to go. Who was that from? Oh, that was from Amanda. Cool. Good morning, Amanda. Also, thank you very much for sharing the stream. Amanda has done that a couple of times recently. When I've posted about it on Facebook or wherever, she has shared it. So how do I get to a list of viewers? It's showing 0 viewers. Anyway, okay, let's go back and do this the old-fashioned way. I'm just going to look through the chat. Oh, hang on. It has just popped up. It looks like the
Remember,
portal.
You can click the members to mark as hello.
Yep. Thank you. It looks like the portal is catching up now. So the members list just populated. It was sitting there empty until now. So good morning to Crispian, Mitchell, David, Ecognito. Tabraze is here from all the way around the other side of the world. And where am I? Amanda. I've already said good morning to Amanda. And I'm just going to move this. Chaos today. Did I say hello to Stephen W? I think I did. Stephen George is also here, and Scott, and Gerald42. Peter, you're here, Peter. Awesome. So you're not working on a Sunday morning. I think that's been a reasonably common thing recently, isn't it? Some call it fun is here. David Howes, Russell Rainey. Dodgy Brothers has made it to the start. Welcome, Dodgy. Jeff Lethbridge is here, and Tassie Bob. Sorry, each time I click a name, it does like a transition where the whole screen grays, it fades out and then comes back. So I can't read the next name for a little bit until it has re-rendered the page. Tassie Bob, Delane, Paul Gray, Shubham is here, and Any Mules, Cable Tie, Imi, Henrik, Paul. Paul Schultz is here as well. I'm just going to click a bunch of these. And, oh, Muddy. Muddy is here.
You want to show them? Yeah, Toto some fixes lol.
Okay, let's see. This is what I'm looking at. Press the button. Here we go. So, yeah, I'm going to click on this one. It just sort of goes out of focus for a moment, and I've got to wait for it to load. So good morning, Muddy. There we go. All right, so how is everybody today? Let's have a quick look. Oh, I saw that there was a storm or severe weather warning for New Zealand issued, I don't know, an hour or two ago. So I hope all of the NZers are okay. It looked like it was mostly up around North Island and looked pretty, like it could be potentially pretty severe, so stay safe. Coffee. I'm just quickly scrolling through the chat. Scott, yes, this is a good observation. Scott
It takes
said,
so much power, it browns out his computer.
Scott said, last week squirrels are taking over the stream today. Exactly. This whole thing, the thing I'm going to be talking about now, is coming out of a squirrel that we were chasing last week. Okay. Oh wow, I just saw Crispian just said, I've had my wisdom teeth out, so I'm smiling oddly. But at least you're smiling. Oh, Peter, you're on rehab from a workplace injury. Ooh. Oh, that's no good. I think the text-to-speech might be about to catch up with that. We shall see. Muddy. Muddy said, I'm new to the live, but been binging your YouTube. Well, thank you and welcome. If you click on person search from show their messages. Yep. Oh, okay. So it's possible to look at, yeah. Mitchell keeps adding features to this chat interface thing. It's very, very cool. I really think that could be a product. It's something that you could be doing for YouTubers and charging them a fee. It's like a, I must admit, I haven't gone looking for anything equivalent, but it feels like there isn't anything else like that. It's like a super interface to user interaction. Yeah, it's very cool. Ecognito. Ecognito says, I have an extended family lunch coming up in 2 hours, so joining the channel to help find my Zen beforehand. Does watching this stream really help you find your Zen? I find that hard to believe. But yes, I know that before social events, it can be necessary to build up a stock of energy and be ready for it.
No fees. Open source for life.
No fees, open source for life. Who said that? Who said that? Oh, also, okay, so also having arrived since then, Johnny Begdahl, DIY in the Ghetto, Making Things is here. Mike Carden.
There is no system notifications. At Peter Lawler, you on duty today, grin.
And David T has also arrived. All right, so, Scott also said, the squirrels I mentioned sent me down the rabbit hole of PicoD and the RP2040 SDK. And of course, Peter's priorities are always on, like, right on point. 110 minutes until lunch. We've just started. We've just started, Peter.
110 minutes until lunch.
Yep. All right. Now, where to begin with this? Okay, so very quick recap. Last week we were talking about the test jig, which I still need to finalize a name of, by the way. So when I started on the project, I kept flipping between Testomatic and Testomator, and I don't really like Testomator anymore. I think I prefer Testomatic, but it's all over the place. So, Oh, Scott says, I have a pair of RP2040s blinking lighting to instructions from a computer via USB. Poached eggs on toast for brekkie, says Cable Tie. Yes, but you're here. You're not out on your bike, halfway up Mount Dandenong in the freezing cold. See, isn't this better? sitting at home in the warmth with your poached eggs on toast and being
Tester
comfy.
cool? Call it giggy with it. Ha ha.
Giggy with it. No, Tradie, I'm not going to go with with your suggestion. Where am I? Okay, just orienting myself. I've got the test thing here. The major issue that I've got, well, there are several major issues that I have with the test system, not the least of which is naming it. And I need to figure out how to do a user interface. Last week we were talking about I/O and remote I/O using a Raspberry Pi Pico with an RP2040 as a remote I/O device being controlled by the Raspberry Pi, so that the Pi could run the high-level logic for what the tests needed to be and then send commands to the Pico to drive I/O pins and to read values and to do all of the typical I/O sort of stuff. So that's where the whole Fermata Pico D sort of topic was happening. And then, so that is still not a resolved thing. Although I'm very interested to hear, Scott, that you have been playing around with that. So maybe this is my cunning plan. I talk about my problems here on the stream and I nerd snipe people into going and figuring out solutions, and then they dive down that rabbit hole, figure things out, and then they come back in the chat and say, hey, I've got this working. Here's how you do it. Ecognito 3. No, I am not. I am not going down the path of that sort of naming. So, yeah, so the I/O aspect of it is a major thing. But Johnny says, by the way, I'm not sober. Okay, so that's how you can get through one of my live streams. If that's what it takes, well, I don't know that that's necessarily good, but anyway. Test Eagle, says Muddy. A couple of years ago I probably would have, but now that Eagle is no more, as in, yeah. What came out of the discussion last week was also the issue of how to do the user interface. So far what I have is a chunk of Python which I run on the command line on the test device. And it's embarrassing.
Coffee.
You're right. When that's thrown me. Scott says, Pico D would be awesome if the original dev hadn't lost interest, so now I'm way too deep into tracing and documenting her code. Oh, okay. Yeah, so that's the danger where there is a project which is technically good enough, like it's decent. How do I put this? One person on their own has done something really cool that could potentially solve the problem, but then it doesn't quite hit that critical mass where there are multiple contributors and longevity and sustainability, and there is the danger of code rot. And before you know it, you're 5 years down the track using this particular tool which hasn't been maintained in 5 years, and then things go wrong. There is a compatibility issue with something, like the kernel in Raspbian OS no longer supports something and things break and you've got a problem. It's really sad when that happens, because projects like Pico D look like a really good solution and it has so much potential, but for whatever reason it hasn't had that critical mass where it has a community form around it and then you can have some sustainability. Okay.
The people demand Steph and Steve proof of life.
Okay. Peter is making demands. since the people demand. All right. Steve is alive. Steph is alive. But of course, is Steph Steve? You didn't see them at the same time. You have no idea. You don't know. I am losing the plot. Which is all normal. Dodgy said, Erica asked why I left a couple of millimeters of wine in a glass in the fridge. I said I didn't want you to be able to say you drank the whole bottle last night. Good morning, Alistair. Oh, and also Trady and John Whips has arrived, and Andrew Gordon is here. Welcome to the stream. Crispian says, I don't need a plot. I don't need a plot. Now, where...
You don't need a plot.
I don't need a plot. I do not need a plot. Let's drag this over here. Move that over here. And I'm going to move this carefully because it's actually plugged in. As you can see, it is powered up. There is the power LED. And in fact, if I hit this touch screen, it should wake up. Come on, there we go. So we've got a touch screen on it. And that is going to be very important today for our discussions. What else do we have? What have we got plugged in here? I've got cables all over the place, so I've got to clean this up. All right, I don't need that USB cable. This USB cable is plugged into, oh, this is one of the brand new ESP flasher, ESPF IDCs. I will show you, in fact, I'm going to show you that because it's cool. This is a CP2102N based USB to serial converter, and in fact, I've got to zoom in on it. We'll hit some zoom, and then I'll zoom back out in a moment. Okay, I've got to fix the focus. Right about there. It'll jump back out in a second once focus assist exits. Now, so as some of you may remember, a few years ago...
For them cables, John.
Yeah, I should. I'll get Cable Tie to come over and hold them for me. So a few years ago I did the ESP flasher. I'm looking around. There'll be one around here, close somewhere. Oh, here it is. There'll be one in here. Yes, actually this illustrates exactly the problem that I'm addressing with this last one. And yes, we are chasing a squirrel. It's kind of a related squirrel, but still it's a squirrel. So
It's not overrated.
This was the original ESP flasher, which had the 1x6 header on it. And the idea is that this is, apart from the extra pin, this one on this end, it is the same format as the programming header in the early Sonoffs. The only thing is that it's got the addition of the, what is this one? IO0, that's right. So it's got the boot mode pin added on the end, but apart from that, the first 5 pins match the programming header in the Sonoff Basic. So this was intended to be for reflashing Sonoffs as easily as possible. Just plug in a USB cable, put it into bootloader mode, and away you go. You can reflash your Sonoff. And the plan was that this format of header could be used as a general purpose header on other projects as well, not just on Sonoffs. And I defined it in 2 formats. So there is the 1x6 format and there is a 2x3 format with an IDC connector on it. And I've ended up using this on many, many projects, like that header format, but I haven't used the 1x6 so much. I used the, and so what I did was I did this little adapter. So this adapter goes from the 1x6 and it gives you a 1.27 by 1x6, and it gives you this IDC thing, and it gives you this IDC thing at the 2 different pitches as well. So I would end up with this sort of rat's nest of cables sitting on the desk, and it was a bit of a pain when the only thing I ever used was the IDC output. So recently I designed a version of the board, this one, which is just the IDC cable, nothing else. Very simple. And
99 minutes to lunch.
I'm guessing that was Peter who said that. Yes. And I got these little IDC solder connectors, which are really cool because what these allow you to do is crimp the IDC cable into the socket or into the connector and then solder the connector to the PCB. So instead of having a shrouded header on the board and then plugging the connector into it, you have this little low profile permanent connection. And then I've heat shrunk the whole thing so that it's not going to short out on anything, but you can still see the LEDs through it. And I don't know if anybody else is ever going to care about these, so I don't know. I might list them for sale. I ended up making, how many did I make? I think I made 30. I think it was 30. Just because that's how many were on a couple of panels. It was like 2 panels worth that I assembled. So I've made a bunch of these, but they're mostly so that I can have them lying around in my own lab and always have them handy so I can just grab one whenever I want one. And because they are so
Hi everyone. Can you
small,
hold both boards side by side?
put both boards side by side, as in the ESP flasher, the old and the new. There's that one and that one, if that's what you mean.
Is the new board on the shop for sale? I would love to buy one.
Oh, okay. It is not. Who was that? Amanda, who asked that. It is not on the shop. So I don't, yeah, I'll list them if people want them. So I did this for my own purposes, but if it's useful, sure. If anybody else is using this header format, yeah, my lofty goal was that people could end up standardizing on this header format for programming for ESP-based projects, but as far as I know, it hasn't really happened. So yeah, if anybody has that header on their projects, go for it. And it's all documented on the Superhouse site. Anyway, that's enough about that, because I want to talk about Node-RED and what came out of. Sorry, I'm just moving some things around here. Oh, maybe that level of zoomage is good. I think I will leave it like that because I'm going to be showing you this in just a moment. This is the Testometer/Testomatic, and you can see that it is running the Raspberry Pi. So the Pi is here on the back of the display. It's slightly out of focus because it's up high. There we go. So we've got, in this case, it's a Pi 3B Plus. I've also got around the place, where are we? Here is the equivalent with a Pi 4. So there's a Pi 4 on the back of a touchscreen, but this one's in a laser cut enclosure instead of a 3D printed enclosure. I'll just put that aside for now because at the moment I'm playing around with this one. Right now this is powered up live and running. Yeah. So I'm just going to turn this over, sit it on the bench right there, because I'm going to be throwing to this view to show you what is on the screen. And it's a touch screen. As you can see, if I move my finger around and if I tap on that selection, I can do that. So I can select stuff on the user interface. But how did we get here? Let's back up a little bit and I'll show you my silly little experiments, and then we will figure out if we can improve on this. I'm sure we can improve on this. We can make this much better. Much, much better. Rusty to... Johnny says, 2:25 a.m. here. I will fall asleep before your lunch. How are you not asleep? Okay, I'm going to moo. Yes, Crispian. Moo. All right, I'm going to put one window there. I'm going to pull this up and put another window there. Oh, that's slightly less practical. Let's see if I can just change the proportions here, because the one on the right can be very narrow. We don't need much of a view on that. The one on the left, we want to be able to see the debug information, and we want to see the palette and the flows. Okay, so in fact I can make that even narrower. That should work, I think. There. Very nice. Very nice. That's better. All right, so on the left, what we're looking at here is node red. On the left, the flow is, this is the flow. So this is how you would normally be looking at node red and interacting with it, with the nodes within the flow and the relationships between the nodes and these functions and all that stuff, the debug window over here. This is the user interface, the dashboard. So perhaps a little more explanation is in order. Now, node red is, it's kind of hard to explain. It's a way of creating programs using chunks of JavaScript and linking those blocks together. So it's like a building block based programming environment, which is with the management all done through a browser. So this is in a web browser and it's all drag and drop and that sort of thing. And you can, create links. It's like creating a dynamic flow chart in the browser and having it executed on the remote device. So at the moment, I am on my local computer. This browser is running on my Mac, which I'm sitting in front of, which is running the stream, but I'm connected to tester 2 port 1880. So the things that we are looking at here are running on that test jig. They're not running on my local computer, they're running on the test jig. We just happen to be looking at it through the management interface using this browser. Wagon Loads said, building block flowchart. Cable Tie says, graphical drag and drop programming environment. Scott says, Node Red is coding for people who hate typing. Paul Gray says, functional block programming. Paul Schultz says, flow-based message handling. Yes, it's... all of those descriptions are accurate and better than my own. Ooh, interesting. Alistair said, pro tip for Node-RED, function nodes are super powerful and most LLMs are pretty good at creating code for the function nodes. That is an interesting idea. I am still trying to get myself, so for context, for those of you who don't know, Alistair is very big into using LLMs and I think more broadly machine learning in general for as a tool for achieving things quickly and efficiently. And so I have not yet got into that mindset of when I have a problem, ask an LLM for help. But Alistair is well there. Taking advantage of all of the latest tools. I just don't think of it. So hang on, I got a cough. I don't know if that helped at all. I think I still sound just as bad. Which reminds me that when Andy was over here a week or so ago, he got me to pull up ChatGPT and ask it to create Verilog for a 4-bit adder, and it just did it. So, yes, doing FPGA development in the age of LLMs is very interesting. All right. Scott says, LLMs are a great way to create just barely functional code. And Alistair said, LLMs are good as junior devs, just need to steer them in the right direction. Yeah. Wagon Loads asked, can the Node-RED Java be saved and run on a website? It kind I don't think so. I don't know. But it's not Java. That's right. So it's JavaScript. I don't even know what the back end is written in, like what the Node-RED back end is written in. It could be C++ or something for all I know. But what it is doing is executing JavaScript. If we look inside function 1, for example, this is a chunk of JavaScript. And we're going to get into that in a moment. So this is all JavaScript. Well, yes, it is JavaScript. Node.js. Yes, it's Node JavaScript. The JS is for JavaScript.
Node.js lol JavaScript.
Yep. But then you can do funky things like this. I'm not explaining any of this in a logical way. All right. Backing up big picture. The whole reason I'm looking at this is I need some way to create a user interface for running the test jig. What I have been doing, in fact, this is going to be one of those things that is so embarrassing. I'm going to bring something up on the screen here and bring it way, way, way up. All right, so I have been prototyping this with this thing, testrunner.py, and this is what I've been executing off the command line on the tester, and it was kind of like not even a minimum viable product. I would just call it an experiment. It's a quick and dirty script to try out whether I can do uploads to the target and integrate with the receipt printer and the barcode scanner and all of those sorts of things. And so I've basically been treating this as a throwaway thing. Like, this is something that can be used. But it was also to experiment with structure. So what you can see, for example, if I look in the targets directory, I've got a series of subdirectories, and then in each of those, like say, I'll just look in gym. And gym, also you'll notice that there are some client names and client product codes and things shown here. What I've got are client names that are clients that it's kind of public that I'm doing work for them. So I'm not disclosing confidential information here. I'm not going to show you anything that is client confidential, but it's very well known that I've been doing work for T-Rex water trucks, and the products that they have, like, I've shown them on streams, and Simon, my client from T-Rex, watches the stream sometimes, so yeah, that's all good. Anyway, the GIM is the joystick integration module. That GIM is just my abbreviated shorthand SKU for the joystick integration module. So what I've got inside each target directory is...
Since when? I never knew. Lol.
So what I've got in each one, in fact, if I do the same thing on MCM, which is the monitor control module, that's the device that actually moves the water cannon, you'll see that apart from legacy, which we can ignore, whoops, that's not what I was trying to do, the other things are the same. Manual checks. Conceptually, this is like, I suppose, vaguely inspired by Debian packaging, where there is a standard within a package. There is a standard for the things that are in that package, like the pre-install, post-install, pre-remove, post-remove scripts. There are those things that you expect to find in a package. So this is a package for a target board. This is a board that I want to test. So I need to flash firmware on it, and I need to run tests on it, and then print a report for it. And I want to make this extensible so that I can add a new target board without having to rewrite a whole lot of stuff. So there is a split to be found between how much is specific to the target board and how much can be generalized, like pulled out into the top level, so that I don't have to repeat myself every single time. So what I've got is target.ini, which defines a number of things in relation to that this particular target. There is a releases directory, although that doesn't have to be there. And there's an upload.sh and a manual checks.txt. So if I have a look at, like if we just have a look at targets mcm target.ini, you can see that this is a, it's an ini file for Python. So this is a section, so DUT is device under test, and then we're just defining a few variables. So test version, hardware version, firmware version, the full name of the device under test, the name of the client, and the path to the firmware flasher. Now, I have just noticed that this is going to be an issue once we start trying to execute this out of Node-RED. But we can get back to that. In fact, if I look at, let's see, if I have a look at camboard target.ini, you can see that this is what I've been messing around with in the last couple of days. We've got the first section, which is the device under test.
Outside the box said, moo.
Moo. And then I've got the overrides, and the difference is that these variables have to be set for every target. These variables don't have to be there, but if they are there, they override whatever is set as the default configuration for the test runner. Okay, where is Sion? I don't know. Where is Sion today? He's probably frozen solid in his factory. He's sitting there as like a solid block of ice. Hang on, I need to cough again and have a drink. Ah, nice refreshing water. Yummy. Where is Sion? Who is Sion? I don't know. Unexpected maker. Have you seen Sion? Okay. Now, I know this is not Node-RED related. I am going to get to Node-RED. It's a coffin, coffin. Thanks, cable tie. All right. You didn't miss anything, Sion. Nothing at all. So, yeah, so this is the definition for one of the device under test thingies. All right, so what else is in that directory? Good question. Well, let's have a look at upload.sh. This is just a call out to ESP tool with all of the arguments, and it's got the path to the precompiled binaries. And those are sitting in that directory. So if I have a look in, what am I looking for? Targets camboard, you'll see that these binaries are sitting in that directory. Now in that other one where I had releases back up here, that's what's in that. It's the structure is kind of arbitrary, because as long as this upload script knows where to find the relevant things and push them to the target board, it's all good. So in this particular case, with the CAN board that I was just setting up, I just dropped them into that target directory. So this target directory is kind of a minimal example, the one for the CAN board. It's got the upload script, it's got the target definition with like the name of the client, the name of the board, all of that sort of thing. Oh, and the other thing is manual checks. So this is just a text file. So if I, whoops, what is Catman? I only got to that because I didn't quite hit space when I was trying to hit Catman tab. Catman, I don't know. I fight for the users. Cat targets, CAN board, manual checks. Okay, that's right, manual checks. This is just a text file. And this is simply a chunk of stuff that will be printed out on the test docket that comes out of the receipt printer, so that whoever is running the test on the board has this as a checklist on like a physical printed out checklist that comes out of the label printer. I keep saying label printer, it's a receipt printer. Like a thermal printer, like the thing you find in a supermarket. And then they can do those checks and tick them off on the boxes and stick the piece of paper in with the board. So that's all that's for. The manual checks.txt is just a text file that gets inserted into the test report. It doesn't actually do anything other than provide a series of checks for the operator to look through. Dodgy asked, where's Austin? That's a good point. We haven't seen Austin today. Oh, Jordan is here as well. Looks like a few more people have arrived. I've already said hello to Alastair and Sion. Wagon Loads is here. Jordan Reese is here. An Englishman in Brazil. KHT. Mechatronica Made. And Huggy D1. Welcome to the stream. We can rebuild him, but it will cost $64 million. Sorry, I was just saying Sion's comment about the freezing pipes. Okay, now the end result of all of this is that, now let's have a look in testrunner.py and you'll see that it is a total mess of stuff. You can see there's lots of stuff commented out. There's, yeah, this is my quick and dirty experiment. So I'm just defining who ran the test because a lot of this should come from the user interface, which didn't exist. So I just I just stuck a few values in here and with the idea that these values, like who is the person running the test, that's going to come from somewhere, but that somewhere didn't exist at the time. So I just made a variable and did that, etc. And here, for example, I could do it so that when you run this script, it asks you for the SKU of the device under test, but then I commented it out and I just hard-coded it to CAN board so that I can just run this script repeatedly and it'll just always be a CAN board. What about your semicolon? Asked Wagon Loads. This is Python. Yeah, and then it asks for the serial number. So if the typical situation is you're sitting down to test a whole bunch of boards and they'll all be the same type of board. So it might be a bunch of CAN boards, it might be a bunch of GIMs, it could be a bunch of MCMs, whatever. You're doing the same type of board over and over again. That'll be the same, but the serial number will be different every time. So what I do is I throw up a prompt asking for a serial number and I take it from the input and I have a barcode scanner plugged into the tester. The barcode scanner just pretends to be a keyboard. So when you zap the serial number sticker that's on the board, it types it into the input and hits return. So the way to run this test is you launch the script You zap the barcode on the target board, and then everything else just happens automatically because it gives it the serial number and hits enter, which means it proceeds. So DUT serial equals serial barcode, and check here for integer value. Yeah, all these things that should be happening and they're just not happening. All right, so then the device under test directory is in targets, blah, 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 blah. So it's just looking for whether that exists based on the SKU. So in this case, it's camboard. So it's going to be target / camboard / blah. If it doesn't exist, end the universe. Sets up some timestamps in different formats, which is probably a horrible way to do it, but I don't know what I'm doing. And then it looks for a reports directory and makes it if it doesn't exist, and then puts into DUT target. Oh yeah, DUT target. Okay, so it's, sorry, I've got to reinterpret this. So it's making a directory for the target device, so camboard or whatever. So if it's a new device that you're testing for the very first time, it'll make a directory to put the report
Scott
into.
Miller said, "That can't be real Python. It looks to have been written intentionally."
Do not blame my code of looking like it's intentional. So print file, now this thing here, the print file, this is the text file that is going to be the actual report. And then this is the file, remember we were just looking at that manual checks text file. This is it. So it's saying the manual checks file is there and the config file is there. So it's just setting up the paths to the files. So then what we've got is we create a config parser object and we read the config file. So this is the target.ini, and that's where it pulls in all of those variables. So you can see client name, for example, is coming from the DUT section of the target file and the client name, and then the actual device name, etc., etc. And then these ones are the enable printer, enable photo, and install firmware variables, and it gets those from the override section of that target.ini, but if they're not defined, it just sets a value. So the fallback, this is like the default value for that that config variable, that config option. And if that breaks my brain less. So yeah, they're all just defaulting to true, but they can be overridden in the target.ini on a per case basis. And ultimately the user interface should allow these to be overridden as well. All right, print values, and then here you can see it's exiting at this point, regardless of whatever happens. That's because of the experiments I was doing. This was me just adding these overrides and checking that it was working. So I don't actually need that anymore, I believe. Okay, so it then is creating a file called, with a pointer, file pointer called P, and it's the print file which we defined earlier, so this is where it's going to output the report. And it's opening it in write mode and sticking a header in it. So it's sticking test report, blah, 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 and it's inserting, at the top of the test report, it's inserting these things, the client name, the target, so this is its SKU, so the DUT target would be GIM or MCM or camboard or whatever, and then DUT name is the, the actual human readable name. Then it's serial number. So we're taking the serial, which is an integer, stringifying it, sticking it in there. We've got hardware version, firmware version, who did the testing, the timestamp of when all of this was done, and so on and so on. And then we're doing firmware. So if the flag is set to install firmware, we say we're installing firmware. Oh, and you can see here, this was a hard-coded path to it when I was figuring it all out. That actually does not need to be there anymore because we are now doing it in here. So command output equals os.popen. So we're opening that file and reading it. Well, not that file. We're popen. We are running that script and taking its output back into command output. Okay, let me rephrase that. We are running this script defined by this, and then whatever comes back from that script, we are sticking into the command output variable. And yep, we're not actually checking for the result. We're just displaying the result to the screen. So we do the upload, and then the output of the upload gets printed to the terminal. It doesn't get saved anywhere else at the moment. It says add save here. All right, so then manual checks. And as you can see, there are no other automatic checks. It is just, right now, all it is doing is uploading the firmware. Nothing else. That's a problem for future me. Then we have manual checks, and this is where it just pulls in that manual checks text file that we were looking at a moment ago, and it just sticks it into our output file. So we've put out the header, we've uploaded the firmware, now we're taking the manual checks and appending that as well. And then, and you're going to see the result of all of this in a moment. This hopefully will start making more sense. So then what we do is add a footer onto the bottom of the test report. So we're, in the footer it says what the version of the test was. And that can be important because you can, when you're working on a project, you have a version of your hardware, a version of your software. You'll also have versions of your tests, because you might discover that you need to update your tests for some reason. You need to test for a new thing that you didn't realize was a potential failure. Or like you've modified your test jig, so now you have additional test points, or you've removed test points or something. Tests can change over time, so you need to know the standard or the version to which a test was executed. So if you go back and look at a board that was made 6 months ago, the way you test that type of board now may be different to how you did the test 6 months ago. So in the footer of the test report, it specifically says what the test version was. And at the moment, I'm just using dates for the test version. And then there is a link. Currently this goes nowhere, but this is a whole subject in itself, which I will talk about in the future, but not necessarily right now. This is something that Mitch has been working on, and it is pretty friggin' awesome. Yeah, it's a dynamically generated URL to go to information about that particular device. And then the end closes the file. If the printer is enabled, it calls up this point of sale printer. Know that POS is not the other POS, it stands for point of sale, and prints it out of the receipt printer. So you end up with, you've uploaded the firmware, you've done no automatic checks at this point, the manual checks, printed a receipt, a little docket that you can then do the manual check marks on and then stick it in the bag with the PCB or the product, whatever it is. Okay, so then if enable photo is turned on, it defines an output file. So you can see that it ends in .jpeg, and this is where it's going to send the photo, and then it calls FS webcam, sets a resolution, and takes a photo of using like a USB attached camera and stores it as well. So what you end up with is a photo in the clean room in there where I normally have the test jig set up. There is a webcam sticky taped to a shelf directly above, looking straight down onto the area where the boards are being tested. So we have a photo that is stored of the board at the conclusion of the test. So later on, if we want to look at the history of the board, we can look at that photo. And that's it. That's the end of the file. And our unexpected maker says, read up about f-strings, please. Okay, I will read up about f-strings. Oops. Wagon Load says, I'm not sure if you said, does your code save the DUT report to a text file or does it create a record in MySQL? Aha. The answer to that is actually not that straightforward. Right now, let's have a look in reports. Reports for, let's say, Jim, does it have any? No. MCM, does it have any? Yes. Okay. So let's have a look at where this stuff is going. Now, if we have a look at reports, MCM 2167 TXT. Okay, so this is a text file. So when it is doing all of this, it is creating a text file on disk in the reports directory, and this is what then gets sent to the receipt printer. And this is the outcome of running one of those. You can see that it's inserted the header at the top, said who the client was, the serial of the device, and when the test was run, who ran it, installing the firmware, and then it's got this manual checks section. So these are all the checks that get done, and it's got things like, is there a desiccant in the bag with the board? Has glue been put on the capacitors? Has conformal coating been done? Have you removed the tape from the piezo? You know, it's got all of these sorts of things that you have to make sure are done for each board. It's got the version of the test that was executed and a URL that currently will not take you anywhere useful. So if you try to go to that, it's not going to get you anywhere. So that's just the text file. This is what ends up on the test report. And then there is the JPEG. This is the photo of the board that was taken when that was all being done. So at the moment, okay, so to answer that question, who was it, Scott? I can't remember. No, Wagon Loads was wanting to know where this test report was going. Right now, it is being stored as a text file on disk on the test jig and as an image on the test jig. But this is where the work that Mitch is doing comes in, because he has, I'm not going to show it right now because it's still very much a work in progress, but there is an online system that will be accepting all of this, which has all of this in a database. So we have all of this is currently in a spreadsheet. So every single device, like if I could look up on the spreadsheet serial number 2167 and see the history of that device. And what Mitch has done is converted that into a MariaDB database with a web front end on it, so that we can search for serial numbers and we can add devices, and there's that is going to be a whole thing in itself. So I'm not going to get into that too much right now, because what I want to do is get back. So all of this has been context for Node-RED. So the point of all of this is, oops, I haven't got that alias set up on here. The point of all of this is that this system kind of works as a Python script. So as a proof of concept, I can run this script on the command line, and I've done this on, I don't know how many boards have been run through this now, maybe 500, something like that, which have had their firmware flashed and stuff using this system. But this is being executed out of, just off a terminal. So if I have a look on, oh no, it's a different screen. So what I need is some kind of a user interface that does not require you to open a terminal on the tester or SSH into it and then run this script in order to do the upload. I want a much nicer user interface. And that's where the whole Node-RED things come on. Tabrez said, are these checklist items done in sequence? Usually you want to conform or coat before removing any seals on piezo devices. Yes, that is true. The sequence of things has tweaked a little bit over time. So if I have a look at TAG, MCM, manual checks, look at the sequence. So we've got tape, yeah, your point was tape removed from piezo is before conformal coating. In reality, that would not be done in that order. And there have been a couple of things where, so what I've tried to do, how this started was, I did not really have a formal test process for these boards. It was just kind of in my head. And like a board, I would make a batch of boards for a client and then I'd think, oh yeah, I need to test them. So I would just do a bunch of things and try to remember the things that I needed to test. So then when I decided, okay, I need actual formal test processes for these things, I started with a brain dump. I had some boards and I did a bunch of tests on them just from memory, and I wrote down what I was doing as I did it, and then I started thinking, okay, what else do I need to do? And dumped it all into a text file, and it wasn't necessarily in order. It was in whatever order it occurred to me in my brain, and then over time I've been reordering the text file to try to group things like, yes, when you're checking that it moves, does it move left, does it move right, does it move up, etc. All of these things. So for example, where it says moves left, what it should do is say detects left limit as the next thing, and then moves right, and then it should have detects right limit. You know, it really should be in the sequence of the things that you do it. But that is a thing that I am improving over time. So I am progressively editing these test procedures and improving them so that they reflect the reality of how it should be done. So that's the short answer to that is, you are correct. Tape gets removed from the piezo after the conformal coating. Alistair said, a little bit of OpenCV will help you automate some of the physical checks. Yes, I really hope so. There are so many things that could be done with this, and I want to add thermal imaging as well, so I can do temperature checks, and also all of the sensing being done through the test jig, like the current sensors and all of the test points, both input and output. Lots and lots of things. So many things that can be added into this. I'm trying to create this as a foundation that all of that can be added into. All right, so what I have here is something that if I run it, it works for some value of work. Not necessarily well, it's not necessarily neat and clean, but it works. So what I want to do is have some kind of user interface on it. And not have to, like if I have a look at up the top here, where is it? Come back up here. Yeah, things like down here where I'm setting the target board, I'm setting who it's tested by, and inputting the serial number, those sorts of things. Things like setting the target should not need to be done here in code, or as an argument to the, well, it could be done as an argument to the script. So that is where Node-RED comes in. Yeah, so last week we were talking about different user interface options, like writing a native program that'll run directly on Raspbian and use one of the windowing toolkits, like make a GTK app or something there are so many different ways that could be done, and or using a windowing toolkit within Python so that the test script itself, written in Python, when you run it, throws up a user interface, which could be using WX or whatever. Plenty of options there. And it was through the discussion on the last live stream that I started thinking about Node-RED potentially as a way of making a user interface. And, excuse me, and I started thinking about the way that I use Node-RED for automation around the office. Let's see, if I go to 185, 1880, will that do it? Yes. No, not quite. If I go to that.
Peter Lawler said 52.
52 minutes remaining. Let's get rid of that and go to UI. Yes, okay. So this is the chargers, miscellaneous. Oh, you can see all sorts of stuff on here. So from here, for example, if I click that, you'll see that my office lights have turned off. And now we've gone into mood lighting mode where I'm just a floating head, except for the light coming through there from the front door, all the natural light coming in. No, I'm not going to turn off the 8M because that would rather kill the stream. So printer lights. Yes, okay. If I turn the printer lights on, did that work? No, printer lights didn't work. Oh yes, there it is. Okay, so now there was just some kind of a lag involved there. All right, so that was the lights inside the 3D printer that is in the corner of the room back up behind me. So I got to thinking of the fact that I am using Node-RED as the interface for controlling the lab, controlling all sorts of stuff. Like, come on, did I click you? Yes. Hot air. Is hot air turned on? Oh yeah, that is a... it's not actually on. And this is not actually on. Those are inheriting their values from bench 1. So preheater, I can turn on the preheater, power supplies, I can turn on the factory fan, the reflow fan, lots of things. Chargers, USB chargers. So this is all being done using Node-RED with the dashboard plugin. And the dashboard plugin allows you to define...
Said, Super House After Dark? Grin.
Yeah, Super House After Dark. All of these UI elements relate back to items on a flow. So lab lights, for example, as a switch, is an object, or it's a node here in a flow, not this one. This is, right now we are looking at the testomatic, but this is a different Node-RED installation. But it got me thinking that Node-RED could potentially be a way to very quickly mock up a
Scott Miller said,
user
I
interface.
have one of my screens permanently dedicated to a near UI page for automation.
Ah, cool. Interesting, Scott. So yeah, you've got a page like this open just for automation. So it is touchscreen friendly, which is good. You can just tap on one of these and activate or deactivate things. If you put this browser into full screen mode, then essentially it's like a kiosk, and it's like having a full screen program, and it updates kind of dynamically. So it just got me thinking that provided Node-RED could make the necessary calls out to run scripts, so it needs to do a couple of things. It needs to be able to call out to the test runner program. This is weird that I'm sitting here in the dark. I'm just going to turn these lights back on. There we go. So it needs to be able to call out to things like to run the scripts. It needs to present a user interface where you can select options and have those options pass through to the script. It needs to be able to gather results and trigger events like printing things. So I started thinking, how about just messing around with Node-RED and see how hard it would be to achieve it. And on Friday, I had a little bit of a lull. It got towards the end of the day, and it was too late to start a whole new client thing. And I thought I would just mess around with it a bit. So I installed Node-RED on the tester and installed the dashboard plugin, which gives us these input devices and output devices. So these particular nodes are from from dashboard. Here we go. So dashboard, you can see we've got button, drop down, switch, slider. I won't read them all, but there are a whole bunch of things that you can throw up onto a user interface. In fact, just for the hell of it, I'm going to throw a couple of things on here. A color picker, a gauge, I don't know, a slider. Is this going to work? I don't know. But the interesting thing is, okay, so all I've done now is drag these user interface elements out onto the palette. I haven't even linked them to anything. Like, I haven't configured them. I just want to see what happens. So watch on the right hand side. This is the user interface view of this flow that we're looking at. So I'm going to hit deploy. Yeah, they're not configured, but stuff it. I'm going to deploy them anyway. All right, so nothing came up. Probably because these are not configured. So slider, where do we want these? Label, slider, blah, output, message.topic, slider. Where should I send the output of the slider? Maybe to the gauge. Let's just see what happens. Slider. Oh, now we've got a slider that we can move, and it's just appeared on the user interface. I didn't even have to reload the user interface. It updated. Now the gauge is not working. Why is the gauge not working? Okay, let's see. What is it taking? So it's taking units from 0, blah. Hang on, let's see what the slider is outputting. It is going from 0 to 10 in steps of 1. The output is going to message.topic. Okay, so the gauge, let's take this from label gauge, value format value. Where is it coming from? Should be coming from message.topic. Ooh, donut. I want a donut. Size, auto, that'll do. There are probably people yelling at me that whatever I'm doing is like this. Value format. Should that be message.topic? I don't know. Let's just find out what happens. See if it's going to come up with an error. Oh, look at this. Message.topic. Look, now we move this slider and the donut changes. So I don't think I've used either of these UI elements before. Hadn't looked at them. This is like how easy it is. It was, let's try this out. We'll take a slider input and we'll create a gauge output. So let's change the gauge from donut to gauge. Deploy. Yeah. And let's see what our user interface looks like now. Oh, so now we've got a gauge. So now as I slide this across, the gauge moves. And you can see message.topic is appearing here. So whatever I value format, message.topic, is there a label, units, value format? Can I just get rid of that? Class, name. Yeah. if I get rid of this, will it stop taking? I don't know. Let's just call this test. See what happens. Yes, deploy. Okay, so that's better. So that is just called test. All right, so we have a very quick way of being able to create a user interface which runs in a browser. And we can create drop-downs, text inputs, sliders, we can do outputs. So this is a text input set in number mode. In fact, that comes from here, serial. So this is a text input node, and what I have done is given it a label of serial. I've put it into mode number, and it's got all these different types of things that you can select from. There is a delay in milliseconds, and what happens is that if you are typing a value into this, it's going to send whatever it is. You don't have to hit enter. Whatever is typed into it, it'll send after this delay. So normally it's like 400 milliseconds or something. I decreased it to 100. If message arrives an input, pass through to output. Send value on focus leave as well. Yep. When change, send current value. And what I did in this case is I modified it so that it is setting it to a global variable. So it's just setting a global called device serial based on whatever you put into this. So if I get, where is it? Serial, set serial. Global.set. Okay. This is from my experiments on Friday. I don't know which one's working. Is it because I'm doing a global set device serial of the payload? Maybe. Yeah, so you can see that this is not actually connected to anything else. All it's doing is a user input, which is setting a global. And that global is then referenced elsewhere. And then we've got a two-stage thing here with two drop-downs. We'll get to that in a second. We've got a start test thing in the middle here, which does a call out to, it does a system call, an exec. We've got the slider in here. Let's see, I want this color picker to do something. Where is this, what is this going to be? Label. Let's give it a name, hex value, round, show hue, whatever, I don't care. Message.topic, done. And deploy. Do we get a color picker? Yes, we do. Okay, so we've got a color picker here. If I click on this, I can go, ooh, I want, well, you can't really see it, that much of it because it's behind my head, but yeah, as you can see, I am selecting a color. All right, don't care about color. Let's get rid of that and do deploy. And now our user interface doesn't have a color picker anymore. Anyway, point being, very, very quick way of mocking up a user interface, adding widgets to it, configuring them, linking them together, and then having the outputs of those UI elements causing other things to happen. And I'm going to get rid of that. Oh yeah, there are a couple of other things here that I've disabled. Let's get rid of these, and we'll just simplify it down to some basics. And yeah, okay, so these things are setting, it's allowing us to select which client we're doing this for, which device it is being done to, and setting the serial of the specific device. And then there is a button here which is start test. So this node here is this big start test button, and that calls out to a function, and we'll get to that in a minute. Oh, Paul, sorry, I'm just going to very briefly catch up on chat because I have been ignoring it. All right,
Peter Lawler said, 40 minutes.
Peter, if you want me to be finished that much, you don't have to watch. Stephen said, what is the best way to shrink heat shrink in
Peter Lawler said, well, 39 now.
39. What is the best way to shrink heat shrink in bulk? I'm currently using hot air without the nozzle on and it's slow. Yeah, I don't know. People probably use like a paint stripper, like what you get a hot air gun, not a surface mount reflow type hot air gun. I'm talking about, you know, the big ones you get at a hardware store that you use for stripping paint. Get one of those and mount it, clamp it or something so that it's vertical, it's just pointing straight up, and turn it on, and then you can put the thing, whatever it is you're wanting to heat shrink, over it. I think that sort of thing. Cable Tie said, also read up on differences between :X and :WQ in Vi. Okay. I've got lots of homework to do after this stream. Oh, Cable Tie already answered the question about the heat gun. Yes, I gave the same answer as I did before I did. So Alice was talking about OpenCV and said, talk to me offline. I've done a bunch of OpenCV recently. Awesome. Yeah, and David said you could also detect if things like tape has been removed from the piezo as well with the camera and image recognition. Yeah. My general approach with this is, if I go back to here and I do yeah, if I look at this, okay, so this is a report for a cam board. Now, I've very consciously broken this into two sections, automatic checks and manual checks. And at the moment, the only thing in the automatic section is installing the firmware for this particular target. And then in the manual checks, there are certain things that that probably have to be checked manually, like serial sticker on front, although that could be figured out using OpenCV probably. Dragino header fitted, etc., screw terminals fitted, that could be checked using OpenCV. There are things like accelerometer detected. At the moment, that is a manual check by reading the output of the serial console. So whoever is doing this looks at the serial console, and in the console it says detected accelerometer, blah, and detected temperature sensor, and it gives you the temperature output that it's currently read. Now, those could be automatic checks run through the tester. So my goal, okay, this is the game. Once I get to a certain point, the game is going to be take all of the manual checks and progressively moves them into the automatic check section. So what it becomes is a game of, okay, is this item here, accelerometer, I don't want to have to check that manually. I want it to be automatic. What do I need to do to make that check automatic? And then do the coding necessary through the test jig to be able to query the device under test and check that the accelerometer is actually responding on I2C or whatever the connection happens to be, and mark it as passed or failed automatically. So over time, I want this section to become very, very big and this section to become very, very small. But this is it's an iterative process. I need to start somewhere, and at the moment I have a basic framework and I have a whole bunch of manual checks, and then I want them to become progressively automatic checks, and ideally manual checks should be effectively zero. There shouldn't be anything that has to be done manually. You should put the board in, press a button, and it gives you a go, no-go output, and if it's no-go, it should tell you what went wrong, so that you can then do rework or whatever is necessary on the board. And it all gets stored, and then the results are all accessible in the customer portal, so my customers can see. They can log in and see the reports and photos and everything for every board that I've done for them. That's what this is all about, and that's what Mitch is working on. So, yeah, progressively moving towards automating all of those checks, some of which will involve querying the target board over the serial interface, like talking to the board and asking it for things, or parsing debug output that comes back from the target board. Some of it will be electrical connections to the board, so driving I/O, like a pin on the board using the pogo jig, and reading values coming back, reading the state of outputs on the target board. And some of it can be done using OpenCV or whatever other methods we can bring into this whole big weird thing. Okay, so Wagonloads asked, does Python have a function that allow URL input like script.py $ID equals 1234? Ooh, I think I know what question you're asking, and I'm going to get to that in just a second, because that is the next thing in all of this. Oh, Alistair said, I've been using Grad.io recently for rapidly building UIs in Python. What is Grad.io? Gradio. Gradio.app. Is this the Gradio that you're talking about? Build and share delightful machine learning apps. Import Gradio as Gradia. Greet name, hello. Interface, blah, and it does that. Okay, that's another interesting thing to check out. Excuse me, hang on, I got a cough again. And more water. More water. Whew. Okay, so I think I might have read this one earlier. Paul Schultz asked, have you considered using a Home Assistant for GUI? Has a Node-RED plugin? Yes, I've considered that, and I think, well, for general automation for the house, yes. For the tester, I think it's probably a little bit heavyweight when all I need is a small number of inputs like this. And I think using Home Assistant to run the tester would be a little bit too much infrastructure. Okay, so okay, so Scott said you can use the exec node to have Node-RED run scripts and programs. Yes, exactly, that's what this is. This big orange thing right here, this is an exec node, and I'm going to get to that in just a moment. I'm just trying to catch up on chat. Cable Tie said, I missed the magic source. How is the web interface and UI created? Okay, so the magic source is that I have installed, where is it? Manage palette. If I go to nodes, I've got Node-RED contrib, here we go, Node-RED dashboard. It's probably quite small on your screen, but the plugin that I installed is called Node-RED dashboard. And if you install that, what you get is, oops, I shouldn't have collapsed it. You get all of these new little nodes that you can call on, including button, drop-down, switch, slider, text input, etc. So what you do is you put these into your flow. You have to define, there are a couple of things that I haven't shown you. There were a couple of setup steps because when you first create it, you have to create there's a group, and then you have to create a group the very first time, and then the group goes within a tab. So you have to create a tab the very first time. So I've got a tab called Superhouse Test-O-Matic, and then inside that there is a group called Default. And that's why up the top here it says Superhouse Test-O-Matic. There could be multiple tabs, there can be multiple groups. I've just got one tab, one group, so it's like a minimal installation. But then once you've done that, all you do is bring in these things. Like I'm going to bring in a button, and I'm going to, what am I going to do? Let's just, doesn't matter. I'm just going to take it to this debug node just so it goes somewhere, and I'm just going to click deploy, confirm deploy, and the user interface updates, and there should be a button. Oh, that's because I haven't configured it at all. Message topic. That's all. I think all I needed to do was open the defaults and close it, and that'll be enough. And then what you do is you go to your Node-RED URL, but you add UI on the end. That's it, just UI. And then you get the user interface version of the flow that you're looking at. Well, of the Node-RED installation that you're looking at. So I'm going to do deploy. And look, now we have a button called button that doesn't do anything except send its payload to the debug node. And then if I delete that button, doink, and redeploy, the button will disappear from the interface on the right. So we are dynamically updating the user interface by changing it in here. Okay. Ooh, very interesting. Aaron said, okay, will the chat say it? I don't know. I will say it. Yes, so Aaron's point was, founder and maintainer of Node-RED, Nick O'Leary, has created Dashboard 2, created by his new FlowFuse company. It's supposed to be way better. Let's click on that link. All right, because one of the things that I did notice is if I come into, actually if I go to, well, this is Node-RED Dashboard 2. Node-RED Dashboard, let's ignore that. Yeah, this one. This is the plugin, and I noticed this when I was looking at it the other day. Look at this. Note. This project is based on Angular v1. As that is now no longer maintained, this project should be considered to be on life support. Small patches will be applied on a best can do basis, but there will be no major feature upgrades, and underlying security breakage may occur. So that is the current status of the Node-RED Dashboard plugin, which is what I'm using right now. Oh, and look, you can see some examples here. This is an interface created using this. Prerequisites, install, blah, blah, blah. All right, so I had noticed that this is, essentially it's deprecated. Life support mode only. So maybe I need to be switching over to FlowFuse. FlowFuse provides a complete platform to manage and scale your production Node-RED applications. Interesting. Okay, so it's like a high-level thingy-majigamy. FlowFuse Node-RED Dashboard. Available in the palette. Okay. I am going to check that out. Thank you very much for pointing that out, Aaron. Because I had been wondering about what the deal was with, yeah, Aaron said not FlowFuse, they just created the custom Node Dashboard 2 for Node-RED. Yeah, I understand that's two different things. So FlowFuse, it looks like a management, it's like a meta wrapper for Node-RED. So if you've got Node-RED installations running on different devices, this is a way of managing your Node-RED infrastructure. And Dashboard is a plugin for Node-RED. So they're two different things, but they both look interesting. So where were we? Back to here. Okay, let's stick with the Stone Age stuff for now because this is what I've got installed. And you don't need Flow Fuse. That's just a hosted platform for Node-RED. Yep. Thanks, Aaron. Very groovalicious. All right. So the point is, with this very small number of things, and in fact, we don't even need this debug node. We don't need these. This very small number of things is actually pretty much all we need to create a user interface for the tester. There are a couple of other things that would be nice, like having more. At the moment, I don't have any output, really, some feedback to show what has happened.
Said, squirrel and install the dashboard v2 and see what we can do.
Yeah, install the dashboard v2 and see what we can do. Yeah, okay. What's the time? Maybe we might have time. And Aaron said, or just go custom like the UT61E web UI in Node-RED. Yeah, that's true. So we could go full custom. But if there is a toolkit like this, which allows us to very rapidly just drag in new things and experiment, then this is cool. All right, so I'm going to show you what I have. Okay. What am I going to do? All right, I'm going to show you something. This is back to the touchscreen. I'm just going to wake it up. Come on. Wake up. There we go. Okay, so this is, and I've got a mouse over here, so rather than use the touchscreen, I have a mouse. I'm going to get out of full screen here. So this is a browser running on the Raspberry Pi, pointing at localhost 1880/UI. So this is looking at the exact same user interface that we were looking at a second ago from my computer. And this has some interesting implications, because what we're doing here is we have the user interface for the tester on the touchscreen of the tester, just in a full screen web browser. So if I just come back up here and go to full screen, so this is going to go into kiosk mode. So this is just a kiosk mode web browser running on the Raspberry Pi. And if I make changes, all right, you're not going to see me for a moment, but what I'm going to do, well, actually, no, what I will do is I'll switch to this. What I'm going to do is bring back in a button here. I'm going to hook it up to there, open it here, click done. All right, so I have just added a button to the user interface, and in a moment I'm going to click deploy, but I'm going to do it while you are looking at that view. Okay, so we're not touching anything. This is just the view on the front of the tester, and I'm going to click deploy. We'll see what happens. And there we go. The user interface just dynamically updated, and it added button. So if I click button, and then we come back to this view, we can see in the debug, this is the output from clicking that button. So we've got the user interface on the device, and we can dynamically update that user interface and without having to reload anything. And we can control it remotely. So you can either control it from the... oh, Mitchell says, you need to change the boot.
Mitchell R said, it doesn't do anything.
And then, previously Mitchell said, you need to change the boot so it doesn't load GNOME, but only the browser and directly into full screen like a proper kiosk. Yeah, that's the idea, ultimately. But the cool thing, what I actually like about this is that the tester is a full computer with the Pi.
20 minutes. No, 19. No, 20.
Aaron says, John discovers WebSockets. Mind blown. Yeah, WebSockets are awesome. Yes, and Aaron, that might seem obvious to you, what's going on here, but it's not necessarily obvious to everybody. So the point I'm making is that we now have a user interface that is abstracted via the network from the actual execution of the scripts, which means that we can do it on the local device using the full screen thing like this. And in fact, what I'm going to do is I'm just going to delete button and deploy, and now we've got our user interface back again. So we've got the user interface directly on the device, or I could be on my phone, I could be on another computer, and as long as the tester is on the network, I can pull up the user interface for the tester and control it from anything, which I just think is funky and cool. And it means that I can sit here in comfort at my computer and be doing things like modifying the user interface and making changes to it and pushing it, like saving it directly on the tester. So this is kind of cool. What am I doing? Okay, so this user interface, what we can do is, all right. Now I've shown you that what's happening. Oh no, I haven't shown you. All right, I haven't shown you. So what is going on here? Oh, Tinker has just sent me. Hang on, I'm going to open Discord, but I'm taking you off screen sharing because I don't know where this is going to open. Ooh, haha, cool. Tinker, is it okay if I show that? That is a, if you want an example of going full out, yes, I do want an example of going full out. I am going to open that and bring it up on the screen so that other people can see it. Here we go. So this is, yep, thanks Scott. This is a Node-RED dashboard with, like, you can see the colors are a little bit different, but it's basically the same format, and it's a whole lot of charts and status information out here. So server okay, receiver okay, database okay, and it's green. Presumably they change color if they're not. So we've got humidity sensors and all sorts of things in there. Wind direction, which looks suspiciously north at the moment. Inside temperature, so lots of values that get displayed here. And yeah, and we've got these little charts. So this is the sort of thing that I did for my own house. So for the super house, I have all of this sort of thing. Like I've got environmental charts and statuses and things. So the thing is, I'm talking, it might sound like I have just discovered Node-RED dashboard. I haven't. I've had my whole house running on Node-RED dashboard for many, many years, and done a lot of stuff with it. The point I'm making is that I hadn't thought of it as a way of making a user interface for the tester. And now I am kind of sold on the idea. This is working out so well. All right, so what have I done here? Client. We have a drop-down node from the dashboard. Yes, and I should probably look at dashboard too, but I just want to show you what I've got here. So I've got a drop-down, and this is where you can select the client. And there is a placeholder. If you don't have anything selected, it just says select client. And then I've got a number of entries in here. There are more clients than this, but I haven't put in the ones that I have to be secret about. So these are, the Superhouse is listed in there as a client as well, because there are Superhouse boards. Essentially, I am my own client for some things. So you can see there's T-Rex, the water truck company, and a few others. And that gives us a drop-down. So this is statically defined drop-down option, drop-down things. Okay, so what this gives us is this drop-down here, where we can select which client this board is for. So imagine that we are about to start testing a batch of boards and we want to say...
Aaron Knox said, Node-RED can interact with the Pi GPIO as well, so why do anything in Python? Why not do everything in Node-RED?
Aha, Aaron, that is a very good point. If there's time, I will get to that. But the very brief, whoops, where is it? Look at this, RPi GPIO out. This is a node where, say we wanted to make GPIO 23 and it's a we want to set it as a digital output, initialize the pin state to low, and done. And then we want to set that pin and drive it from something else. You can send a message to turn that pin on and off. You can do all of this I/O stuff directly out of Node-RED. It is super easy, but that isn't a whole other topic for now. But yes, that is also another argument for using Node-RED for this. The entire tester could be created entirely in Node-RED with GPIO pins and things from the Pi. But I just want to get through this user interface stuff. So say you want to test a bunch of boards, and so you know that it is for a particular client. So what happens is, say I select Superhouse, and then I want to select the device. I don't want this list to show every single, in fact maybe I should zoom in on that. Can I zoom? Yeah, let's do that. So I don't want this list to show...
Said, unlucky for some, 13.
13 minutes remaining. Every single device for every single client. So this is a multi-stage drop-down where what appears in this second list, see I've got ESP Flasher, IDC version, or Rack32, like I can select either of these. And then if I change the client to T-Rex, the water truck company, I can now select a gym or an MCM. The list is different, so changing the client gives me a different list of devices to choose from as targets that I want to do the test on. Oh, sorry, yet again, cough and a drink coming up. I don't know why. I really need to clear my throat. I'm pretty sure I'm not sick. It's probably just talking too much. All right, so how am I achieving this? How am I changing the drop-down options in the second thing here by changing the first one? Well. The way that is being achieved is I have the client drop-down defined with these options. That is hard-coded. And then the output of it, when you change from in this drop-down, whatever you select is sent out the output and it comes into this function. So this function is very ugly and very simple, but this was me yesterday actually just trying to figure out if this approach would work. So if you've changed the first one to be T-Rex, what it does is it sets a global variable called client to T-Rex. We can ignore that for now. That is used elsewhere. But the important thing for this point is that it sets message.options to MCM, GIM, BIM, and AUX. If you have selected Superhouse, it sets the global to Superhouse, and it sets the message options to ESPF IDC and Rack32. And then it returns the message. So then that comes, wanders along down this little virtual wire and comes into device. So client is a drop-down selector. Device is also a drop-down selector. But if I go into it, you will see that I have no options defined. So you can't select, there is nothing defined in here at all. This is populated dynamically based on the message that comes in on the input. So that is how it gets populated. So what happens is you select the client, like Superhouse, that gets passed to function 1, which then says, oh, you've selected Superhouse. Therefore, the options are ESPFIDC and Rack32. That gets passed through to device. Device gets its options list updated, and now we've got those two to choose from. And then you select that. And then the output of that, because we've just selected it, comes into this function, and all it does is set a global called device SKU. So the end result of this cascading drop-down is we have set a global for the client and we have set a global for the device SKU, which is the target that we're going to be operating on. So we now have 2 of the 3 critical pieces of information. And then we've got a text input which is set in numeric mode. And if I change that value, that sets a global for device serial. So we now have 3 globals set, which can be accessed elsewhere. And that's why this little chunk of stuff here, these nodes, don't look like they're connected to anything. And yes, I know, globals, bad programming practice, yada, yada, yada. But the end result is that this very simple little
Mitchell
collection...
R said, still too much configuration.
Yeah, you're...
Lola said, one fat lady.
Not quite ready to sing. Yeah, Mitchell, you're right. It is too much, still too much configuration, because the configuration is being done in Node-RED, like defining these and this thing here. These should not be in code. This should be coming from somewhere else. Like there should be some other auto configuration where it pulls these off the disk or something. But anyway, that's a future optimization. The point of this was that this was a very... How long? This stream has been going for nearly 2 hours. Okay, so getting this working was a matter of minutes. It was just screwing around with, oh, let's see if this is going to work. And it kind of does. So it's totally unoptimized. It is a first pass. Let's see if this works. So we've got the ability now on the touchscreen, and I can do this on the device itself. Back over here, if I wake it up. Now I haven't got an on-screen keyboard.
Mitchell R said, see my MSG above for config log.
Okay, I will look back at that. So I've got this wireless keyboard and I've got a wireless mouse. But what I can do is go T-Rex, no, oh, that's super.
Aaron Knox said, so click start test, let's see it.
Superhouse, it doesn't actually work, Aaron. But I'll show you what it does do. And then I can select that, and I can select that and make it serial number, 120 or something. I've just changed it on the numeric keypad. So we've now got variable set, and then you can just click start test. So once you've got the client and the device set, when you're doing a batch of boards, you don't need to change those. They will just stay the same. It's just the serial, and the serial can be entered from the barcode scanner because it's just a text entry box. If we delete that, the barcode scanner is in the other room, but if I simply zapped with the barcode scanner, it would auto enter the serial into there. All right. Okay, now we have a start test button. Let's look at what this does. Hang on. So some call it fun said, apparently there is a JSON node that could parse a comprehensive file with all of your hierarchical clients and devices. Yeah, that I am absolutely shocked. Not at all. Yeah, some call it fun. That's a very good point. And also, Mitchell had a post about config. Okay, so Mitchell said all of that could be controlled by the tester top board. So you switch the top board and everything is ready to go. No button but start, which
Scott
could
Miller
also
said, Mitchell is right. The tester board should trigger all those fields.
yeah, which could also
Mitchell R said, UI fix. Start button at the bottom lol.
which could also be a micro switch on the board. Yes, yes, absolutely. So many optimizations we could do here. There are, yes. If you're going to entertain a barcode scanner, you could...
Peter Lawler said, knock at the door.
Really? Should I be scared? Jordan said you can configure almost any barcode scanner to spit out as a COM port. Yeah, well, mine is configured to be a keyboard, which works absolutely fine for these purposes. Some Call It Fun said if you're going to entertain a barcode scanner, you could put one barcode on the test board for the device and then scan the serial number next. Yes, so there could be like an ID for the tester. That's true. So the test board would have an ID that said this is a gym, and you scan it and it puts it into gym mode. Yes, that is a very good idea as well. Wagon Load said, can your test jig overhead cam do the barcode scan? Yes, it can. Yes, and I have done that. That's actually, oh, all right, I won't chase that squirrel, but I do exactly that. When I ship out orders for Freetronics and Superhouse, I take a photo of the package, including the barcodes, like the shipping, the tracking barcode, the tracking number, and the customer ID barcode, etc. And I have a script that processes that photo and it generates an email to the customer with the photo attached to it. Yes, I've done that, all that sort of thing before.
Peter Lawler said, one little duck.
Stephen said, Peter is coming over to drag you away at exactly 12. Scott said, could do the tester board ID through GPIO. Yes, all these things, so many things that can be done. I'm running out of time. So I'm going to show you what this is currently doing. All right, the whole start test thing. So this start test button, and as Mitchell said, yes, start button at the bottom. It should be down here. Yes, it should. So start test, this is the button that you see here. And what happens is that when you click that button, it doesn't do anything particularly useful. The actual value doesn't matter. It just sets a payload of start the test. But we don't actually care what the value
Peter
is.
Lawler said, Kelly's eye. Scott Miller said, squirrel, 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 squirrel.
All we care about is the fact that it has been clicked, so a message has been sent. All right, so function 2, very, let's call this begin test, just to make it more self-contained. All right, what it is doing is checking that the...
Scott Miller said, rabbit hole full of squirrels.
Yeah. Rabbits and squirrels hanging out having a party. It's got a couple of checks. So it's making sure that you have actually selected
said, bingo,
a target device and that you have actually set a device serial. And then what it does is create a message. This is not entirely self-explanatory. Well, for some of you it will be, but anyway, the point of this, what it is doing, it is taking the device ID, so that could be like Jim or Camboard or MCM or whatever, adding a dash, and then adding the device serial. So it's creating a single dash separated thing, which is SKU dash serial number. And then it is sending it on. Not very exciting, but all it's doing is a check. So you click that button, nothing will proceed on from here Actually, this should be inside the check. This return message should be in here. And okay, yes, full of bugs, full of bugs. So the assuming that everything is correct, what it will return is a value that will look something like Jim-123, and it will pass it on. Okay, so what's the point of that? So you click the button, it then passes on Jim-123, and it goes into this exec node. So the exec node calls out to this script right here, which is test.py, and I'll show you that in just a moment. And it is appending message.payload as an argument. And it's got options for timeout and blah, 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 etc. All right. So I'm going to show you test.py. So this is when this button is clicked, summary, when this test button is clicked, it is going to take the values that have been set in these other drop downs and the serial, pass an argument to this exec script. Now the exec script, where is that? That is test.py. So let's have a look at test.py. Actually, that's .py. There's a whole lot of stuff in here because it's a cut down version of the full test script, but it's really only the first little bit that, or is it cut down? No, it's not. I duplicated the test script and then I just hacked it. So you can see that it's doing a hard exit here. Regardless of anything else, nothing below this point matters. So what it is doing is taking the first argument that is passed to it, and it is splitting it on the hyphen. What happened then? Something weird was happening with audio. And it is extracting the target and the serial from that. And then printing out SKU is the target and serial is the serial, and then exiting. So this whole thing is, the point of this is just a test of whether what I select in the user interface gets passed through to the Python script, which can then parse the argument and accept that argument. So nothing below that matters. So if we come to, oh yeah, so we've got a debug node here, and there are three outputs coming from this, from here. So we've got standard out, standard error, and return code. Let's just get rid of return code. We don't need that. Standard error and standard out are both coming to this debug thing, because I just wanted to see what was happening when I ran this script. Then let's just hit deploy. Okay, so what we're going to do is I'm going to select T-Rex, Jim, serial 78. That'll do. As long as I've changed it, it'll have set the global. Now,
Peter Lawler said, "Go home, John."
No. Okay, now I'm going to drag this debug window out nice and wide, and I'm going to click the Start Test button, and we'll see what happens. Ka-ching! Okay, so we've got some debug info. So where this is coming from, this debug, this is the output of having executed this Python script, which is sitting on the file system. And what we've got back is received.
Peter Lawler said, "Oh, okay."
Received Jim 78, SKU is Jim, serial is 78. So we can see that it has successfully, I'll move that over there, switch back to here, come back to here. So what we're seeing is, in fact I'll move this down to make it super obvious. What we are seeing is these three lines here, received, SKU, and serial, we are seeing come back in the response from calling out to that Python script. So
Aaron Knox said, what you got is a string, probably should be an object.
Okay. Yeah. It says string. Yeah, I don't know. That's more than my brain can handle right at this moment in time. So, yeah, it's a string within this. Yeah, this object has this attribute, which is this string. So this string is the value that comes. So payload is that, and RC, response code. RC is response code. Code 0, which means that it exited cleanly. This is the exit code coming from the tester. So that means that we can successfully select a target. So if I now go Superhouse and select rack 32 and it's serial number 781, I'm going to delete that. So we're starting with a clean slate, and I click Start Test. What you can see is we have successfully called out to the Python script sitting on the file system, and the Python script has accepted the argument, it's parsed it, and then exited cleanly. So that means we can use this to invoke the existing test script with a few caveats. We have path issues and etc. Yeah, Scott said standard out is just a string, but if the script outputs JSON, it could be handled as such. That's a very good point. Yeah, so what I could do is in here, yeah, I'm just printing this out because when I was first testing this, of course, what I was doing was test.py dash blah blah blah, like that. Yeah, I was just doing this on the command line to make sure that the script was taking this argument and then being able to deal with it. So it doesn't matter what it is. It's not using it at the moment anyway. Peter, you got to go. Okay. Thanks for hanging out, Peter. Yeah. Okay. Aaron said that's what I meant. I thought it would be obvious, so I didn't state it. Yeah. Okay. So what I could be doing is the script could be outputting JSON, and then that comes back in the response, and we can pull that in and just treat it as an object, and life is good. Yeah, so the response that comes back in here could contain all sorts of stuff. Yeah, so what we've got is user interface in Node-RED that sets some things, allows it to select some options, calls out to the actual test execution script on the disk, which gets executed, and then the output of that script gets returned back into Node-RED so that we can do things with it. That is the very brief summary, and then this whole live stream could have been over in 30 seconds. And we would have all been far happier. So anyway, that is the kind of outcome of my, let's see, view. That is the kind of outcome of my my quick and dirty testing, just to see if Node-RED is a viable user interface toolkit for doing this sort of project. And my conclusion is, yes, it is. It is viable. It's definitely not the only way to do it. It may not be the best way to do it, but it works. And I've used Node-RED a lot in the past. I'm pretty comfortable with it. So let's have a look at, yes, Node-RED Dashboard 2.0. View on GitHub. Let's check this one out. Documentation can be found here. Dashboard.flowfuse was rebuilt from search Node-RED dashboard. Install the flowfuse Node-RED dashboard, not Node-RED dashboard. Okay, is that really all I got to do? That's nice. Palette. Let's check out this Node-RED dashboard. Node-RED dashboard, and not that one. So this is the one that I'm already using, and I want to find. Is it Flow? Yeah, Flowfuse. Here we go. Node-RED dashboard. This one. I'm going to go install. Last update 2 days ago. Yeah, it'd be cool to have a modern, actively developed version of this. Maybe the last thing that I should do on this stream is just see if I can convert this existing little experiment over to use Node-RED dashboard 2. I've got no idea what the differences are, how hard it'll be. Is this doing anything? Installing? I guess it's installing in the background. All right. Aaron said, Node-RED will certainly allow you to iterate quickly, which is most likely the most desirable thing. Yeah. Stephen said, make sure you can trigger wget and execute with root privileges remotely. Yes. Yeah. Okay, so we've added a whole lot of nodes to the palette. Close. Let's see, is there, oh, there's a dashboard too. Okay, so we've got text input form, blah, blah, blah. Just for the fun of it, let's try replacing, does it work the same way? Does it end up at the same URL? I've got no idea. What happens if I mix these together? I'm going, I'm going to, what'll I replace? Let's add another serial thing. So that will be a text input. Let's add a dashboard to text input and see what our options are. I'm going to call this serial 2. Label serial 2 : space, and the mode is going to be group. My group. Yeah, so we're going to have different my group. Let's see how my group is defined. Dashboard page 1 / dashboard / page 1. Okay, so it looks like the URLs are different. Display group name, yeah, that'll do. And then we've got pages. Dashboard page 1.
Said, they are separate things, different C9 NFOG nodes.
Yep, cool. Default theme, layout grid, etc. Okay, my group. So, delay, focus, leave, press enter. Okay, send message on press enter, send on focus leave, send on delay. Yeah, okay, this is better configuration than the previous text node, so that's nice. Let's just do it on delay as well. Payload current value, message topic. That'll do. Serial text. Okay, text input. I'm going to make it a number, and I'm going to, and that's it. I just want to see what this looks like. All right, so we have a serial input there that does absolutely nothing. But let's come to tester. All right. Tester2.local / dashboard / page 1. I think that's the URL that we want. It appears that it is serial 2. Okay, so now we have our little widget on there. Let's take that up into there and do client. So client is a multi-select. So it's a select drop down. Here we go. Drop down, and we're going to call it client, and options let's say T-Rex with a value of T-Rex and value Superhouse with label Superhouse. That'll do for now. I don't want multi-selections, all of that stuff. That'll do. Done. Client. Function 1. I'm just going to copy this function and stick it here because T-Rex Superhouse, yeah. And then I want a device drop down, so I want another drop down, and I'm going to call that device. I'm going to give it no options and take the output from here into here, and I'll copy the set SKU. Essentially what I'm doing here is just trying to recreate what I already had in dashboard 1 with dashboard 2, set device, yeah, setting a global. All right, deploy. Go, 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 gadget thingy majigamy. All right, so now we have serial 2, we got select option, T-Rex, and now we can select from those options. Cool, that's working. So if I change it to Superhouse, it'll now change my drop-down options on the second one. Now, one thing that I just noticed is that when I changed, see how it's Rack 32, which is a Superhouse product? If I change to T-Rex, it does not update the second drop-down, and I think that is to do with a setting in here. What have I got? Clear selection with button. What does that do? If message arrives on input, pass through to output. If I do that, I think it'll clear it. Let's see. So now if I go to Superhouse and select EFPF IDC and then go to T-Rex, no, it hasn't cleared it. Okay, I'll have to figure that little thing out. But anyway, it seems to be approximately equivalent. Get rid of that one. So we have start test, client, Superhouse. Hopefully there are some styling options in here as well. But in any case, this, where are we? Serial, there, set serial. Let's take that down to here. And so what we should have now is that this group of UI elements that are on the first dashboard should be approximately equivalent to this group of UI elements that are on the dashboard 2. Okay. Just needs a little bit of tweaks, and then and then I would need to replicate this as well. Start test. So that's a button. Let's bring a button in here, and we'll call it label. Start test. Message.topic. What do I need to do? What did I have on this one? I don't think I had any. Oh, payload. Start the test. Payload doesn't actually matter. We're not using it for anything. So let's take this node, bring it down here, start test, and take this node. Yes, I know I am duplicating a whole bunch of stuff. Bring it down to here. I'm going to take this debug node, bring it down here, take the first two outputs, because I want to see error as well. I'll turn off the output from that debug node. And what have we got? Select device, done, and deploy. All right, so now we have, on our user interface, we've got serial, and then we've got, so let's see, if I go serial blur, and I've selected Superhouse, and I select the EFPF IDC, let's see what happens now. Out of this debug node, we should get a response coming back. I'm going to go start test, and we've got payload. There we go. We have the output. Hang on. That is the bogus output. That didn't actually pass it through properly. All right, I've screwed up somewhere. What have I done? Message option, when message.payload. begin test. Message dot payload global. Yeah, this is not working. Okay. I think. Anyway. Oh, 123 SPF ID. Oh no, it did work. What am I saying? There was actually nothing wrong. I just saw ESPF IDC, and to me it looked like, you know, random keyboard mash. Oh no, ESPF IDC is what I selected. So if I change that to rack32 and run start test, here we go. We get the output, and it is rack32, serial number 123. So that's working. All right. So now we have this as the can I group that or something? Where is it? Group selection. Can I give that a name? Yes. Dashboard. Dashboard. Dashboard 1 plugin. Okay, so this is controlling it out of the first dashboard, and this is group. Controlling, that is the dashboard 2. Dashboard 2 plugin. Bum, bum, bum. All right. There. Okay. I know, they're different on the left as well. Oh well. So we now have two functionally equivalent user interfaces, one using the original Node-RED dashboard plugin and one using the dashboard 2 plugin. And so we've got the dashboard 1 plugin and the dashboard 2 plugin. Okie dokie. Deploy. So, yeah, seems fine. You typed the field label in the name, I think. It said Aaron. Okay. Okay, so Aaron said, if you go into the page configuration, I think you can reorder the fields to put serial at the bottom like your original. Yeah, so that was one thing that I was having trouble with in the original dashboard. So if I go into, all right, this is for dashboard 2, go into the page configuration, open dashboard 2 sidebar. What does that mean? Aha, okay, so here we've got layout, start test device. Can I edit that? I don't know. That okay. I am slightly stumped by that. It's all grayed out. I don't know if I can edit it or not. Someone beeping outside, but I don't think it's for me. Okay, so let's come into here, dashboard, edit that. Style, collapsing, show page name in navigation bar, let's get rid of that. Include page path in label, and what have we got, page 1. Let's call that Testimator, that'll do. Page 1, default theme. What theme options do we have? I wonder if we can... I wonder if there are themes that you can load into here. That would be kind of cool. Edit UI group, edit UI, yeah, okay. Update. CSS, layout, grid, fixed, notebook. Oh, it's got some other options. So we could change... we could change the way the layout is handled. Let's just leave it as a grid for now. Anyway, all back to there. Hit deploy. Let's see what happens. Okay, so we've got start test. Yeah. I haven't actually changed the order of anything, but oh, it's reversed it. So now we've got the company, and then above that we've got the thing. So the order is backwards, and then serial at the bottom and start test at the top. It's all kind of random. Are the fields in the right column draggable order? Asked Wagon Loads. Oh, yes, now they are. Okay, so I want to go, let's see if I want to start test at the bottom. I want to select client, and then device, and then serial. So let's just change that. And there we go. So now we select the client, we select the board type, we set a serial number, and then click Start Test. And then if we come back into debug, in here, what's going on here? Drag that out so we can get to debug. There we go. There is the outcome. Rack 32, serial number 1234. Now, so, okay, we now have the user interface in the order that we want in the Dashboard 2 plugin, and it is calling out to that test script in here. It's not the full test runner, so it's not actually executing the test. It is just this this one that is taking the arguments, printing them, and then bailing out. But the idea is that if I got rid of that exit and probably need to make some changes further down here. Okay, so changes. I'm gonna bail on this live stream in a second, but you can see, for example, DUT directory. This is assuming that this script is being executed on the command line, and your current location is inside that directory. So it's a relative directory. So this would have to be changed to home Testomatic, test runner, like that. Like we'd need to add an absolute path to it. So what I would probably do is define a path prefix somewhere up here, and then I would, it would be something like path prefix equals home Testomatic test runner. It doesn't even matter because I'm not going to keep this and then it would be path prefix plus target. Yeah, and I would do similar things elsewhere, like where here it is, print file reports. It would be path prefix plus blah. Okay. So I would need to go through and fix it to make absolute paths to all of these things. And it wouldn't just be in here. It would be, I'm going to exit, oops. I'm going to exit without saving that. The thing is that if we look in targets, MCM upload, for example, oh, it's got absolute paths. That's good. I'm pretty sure it didn't in some of them. If we look in Camboard upload, oh yes, absolute paths. Okay, well maybe that would work. But I'm pretty sure that there are some parts like targets, target.ini, oh, Camboard, target.ini. You can see firmware flasher path is targets. So where is firmware flasher path used? Grep flasher path on test runner.py. Did I check for the right thing? I probably didn't. Let's just have a look for path. Anyway, flasher. Oh, Let's look for that. I don't know what's going on. Anyway, doesn't matter. Doesn't matter. The specifics don't matter. The point is, I need to make sure that things like paths are set as absolute, so that when this is executed by node red, it finds everything. But the other thing, of course, is I'm going to need access to the serial port to run ESP_tool. And let's see, grep node. What is node running as? Oh, it's running as my user. Okay, no, that'll work. That's fine. So node red is currently executing as the testomatic user, because that's how it was set up. And this user has privileges to the serial port, which means that it'll be able to do the upload. So yeah, I reckon this is going to work. All right, I think everybody, OS path join says some call it fun. Yeah, I think everybody has probably fallen asleep by now. Aaron said Node-RED can access serial too. Yes, I know, Node-RED can access serial, but what I need to do, what I'm doing here is calling out to ESP_tool, and it is doing the upload. So I'm just doing an exec on ESP_tool, which then needs to access the serial port. So it needs the privileges for the port that have been inherited by the calling process. But that all looks good, because the calling process is going to be testomatic, which is the user that is in the wheel group. But he says, I'm awake, what happened? Oh, yeah. As people keep pointing out, Node-RED can do stuff. Like Aaron said, Node-RED can access serial too. Yes, Node-RED can access the Pi's GPIO pins. Node-RED can do all the things. So, Tabray said it's 3:30 a.m. May as well not bother going to bed. No. Oh, yeah. You'll be a mess tomorrow. Yeah. So, I think, yeah, Scott says Node-RED can do anything on the computer. Yeah. Alistair says Node-RED is Turing complete given an infinite amount of RAM. Anyway, the whole point of this live stream is stupid stunts with Node-RED. And the more I've messed around with this, the happier I am with the idea of using Node-RED as a tool for managing this tester, because I can do, what I could be doing actually is doing the automated tests within Node-RED itself, because you can define, it's got flows, it's got logic, it's got all sorts of, all the programming things, it's got access to all the things, and it is very quick and easy to set up logic within this. And oh look, we got text to speech, we've got all sorts of things. We can write files, we can read files. Look at this, storage, write file, read file, watch files. Sequencing, we've got network related stuff, of course. We've got MQTT. It deals with JSON as like a first-class citizen, of course, because it is JavaScript. So, so storing configuration and test results and all sorts of stuff as JSON, it's all just totally seamless. Yes, oh, and as Aaron says, we've got a UT61E web UI node. Yep. Oh, okay. Yeah. Some Call It Fun says, nice proof of concept. Ship it. Yeah, this proof of concept is good enough for production. Okay. I am just about ready to fall over after 2 hours and 36 minutes of constant talking, which is not my native mode to be in. I am not natively a talker. So I have just used my week's worth of talk budget, but it was worth it. It was totally worth it. Right. Anyway, to summarize, Node-RED is glue. It's a toolkit. It can reach out to the things in the computer. It can pull things in from the computer. You can create a user interface. You can create logic with visual flow. You can access that user interface on the same computer using a browser. You can access that user interface over the network using a browser. It's just kind of cool. So, oh, Alistair says next week it'll be re-implemented in BF. No, we're not going to re-implement it in BF or any of the other derived Turing complete languages. Yes. Oh, Russell was here as well. Who else? So there are a couple of people who joined the chat. Ryan joined the chat. Sharky. Yeah. Anyway, I'm going to go because my brain is about to collapse. I need to... It's like a sponge that has been slowly drying out and getting smaller, and I need to rehydrate it. So thank you very much. And thank you for all of the input and the pointer to dashboard too. I was kind of worried about the note saying that dashboard was deprecated, and I didn't even know that there was a new version. So that is a fantastic find. Yes. Right. Okay. Thank you everybody for coming along. Yes, we're getting somewhere. Node-RED is fun. I like Node-RED. I haven't actually done anything much with it other than using it. I use Node-RED all the time, every day. That's how I control everything in this place. Everything in my lab is controlled through Node-RED. The voice control is done through Node-RED. But I've just been using it. I haven't really been creating with it for a long time, and I kind of forgot how cool it is to create with it, how quick and easy to just go, I want this chunk of functionality, drag it onto my palette, link it up, click deploy. It works. It's yeah, it's a lot of fun. So if you haven't played around with Node-RED, I recommend it. I suggest installing Node-RED somewhere and just messing around with it. It might seem like a if you don't have an application for it, of course, then what are you going to do? But if you've got something where you can interact via MQTT or whatever, Node-RED is a really cool little toolkit to have your hands on. So oh, Wagon Loads asked, is Node-RED good for robotics? No, Nodebots is the answer to that. Here we go. Look at this. Nodebots. Learn how to make robots powered by JavaScript. So what's a Nodebot? It is this. Nodebots. Johnny 5, Inventor's Kit, Arduino, Nodebot software. Yes. All done using Node. So this is not Node-RED as such, but this is Node. But yeah, it's all Node-RED is built on Node, and it can do all the things. So the short answer is yes, you could use Node-RED for robots. Build all the robots. Alistair said ROS is where it's at for robotics. Lots of modules for pretty much everything. Yeah, so ROS, which is Robot Operating System, is the toolkit for building more real robots, but for like school level stuff for kids playing around, and you want to just gaffer tape some servos onto a piece of core flute and stick cat's eyes on it and do some drag and drop programming, something like NodeBots is a really good way to get started. Very quick and easy for making something that reads from some sensors or takes some command input and then moves servos and drives stuff around. So, I was just thinking about ending like Lewis, but I won't. I did hope you learned something. I certainly learned something. So thank you very much for hanging out with me, and I hope you learned something. Now that would be the Lewis goodbye for now. It's goodbye from me, and it's goodbye from him. And I will see you all next time. Thank you.